So here we have a question from mastering, and we are given the name of a compound and that it's a hydrocarbon and it has been burned through combustion, and we want to know the empirical formula. So the steps for an empirical formula are going to be the same. It's just going to be a little bit strange. We've got one extra step that we need to take care of. So a hydrocarbon tells us we only have carbon and hydrogen. So the fact that there's oxygen here is not going to be relevant. So let's do this. 13.2 grams of CO2. Now we need to convert that to moles. So I'm going to kind of try to do that in my head. 12.01 is 2 times 16. 44.01 grams of CO2 is 1 mole of CO2. Okay, now here's what we need, because we need moles of carbon. So hopefully, here's your extra step. We know that 1 mole of carbon dioxide, if you look in your formula, there's only 1 carbon. So that tells us there's only 1 mole of carbon. Okay, so it looks like it's a wasted step, but it's really not. So let's take 13.2. So this is going to round to 0.3. 0.3 moles of carbon. Now we're going to do the same thing with water, 8 grams H2O, and hopefully everybody's okay with me using 18.2 grams of H2O is 1 mole of H2O. Okay, now here's where it gets a little bit tricky. Okay, so 1 mole of water. Now count here how many hydrogens are in water, and there's 2 of them. So it takes 2 moles of 2 moles of hydrogen to get 1 mole of water. So that's the secret really to this problem. So we have 1.8 divided by 18.02, and we need to multiply that by 2. So we get 0.2. That's what I'm going to round to. 0.2 moles of hydrogen. So that's all we have. So now we write our pseudo formula using our moles as subscripts. So C 0.3, H 0.2. Now we need to divide by the smallest one, which is 0.2. So that gives us H1, and carbon 0.3 divided by 0.2 should be 1.5. And hydrogen 1. Now remember, we can't have any decimals, so we need to clear this. And so the easiest way to clear a 1.5 is to multiply everything by 2. So that would give us C3H2. And that's the empirical formula. Now, in reality, it's probably a lot bigger than that, but this is our lowest whole number ratio. So unless it gives us the molar mass of this chrysene, we can't, this is as far as we can go.